Multi-region architecture, global applications. In today's interconnected world, users expect fast, reliable access to applications regardless of their location. Multi-region architecture is the solution that enables applications to serve users across the globe efficiently. This approach involves deploying your application infrastructure across multiple geographic regions to ensure high availability, low latency, and disaster recovery capabilities. Throughout this video, we'll explore how to design and implement globally distributed applications that can scale to meet the demands of a worldwide user base. Multi-region architecture refers to deploying applications across multiple geographic regions to provide global availability, disaster recovery, and low-latency access for users worldwide. Instead of hosting your application in a single data center, you distribute it across strategic locations around the world. This architecture delivers three key benefits: low latency, ensuring users experience fast response times by connecting to nearby servers; high availability, guaranteeing your application remains operational even if an entire region fails; and disaster recovery, providing automatic failover capabilities to maintain business continuity during outages. There are four compelling reasons to adopt multi-region architecture. First, global reach. By serving users from the nearest region, you significantly reduce network latency and improve their overall experience. Second, resilience. Your application can survive regional outages by automatically failing over to healthy regions, ensuring continuous operation. Third, compliance. Many industries require data to remain within specific geographic boundaries. Multi-region architecture allows you to meet these data residency requirements. Fourth, scalability. Distributing load across multiple regions enables your infrastructure to handle massive traffic spikes efficiently without overwhelming any single location. There are three primary deployment patterns for multi-region architecture. Active-passive is the most cost-effective approach, where a primary region handles all traffic, while a standby region remains ready for disaster recovery. This provides resilience without the expense of running full capacity in multiple locations. Active-active delivers maximum performance by having all regions serve traffic simultaneously with intelligent load distribution. This pattern offers the best user experience, but requires more sophisticated data synchronization. Hot-warm-cold uses tiered regions with varying readiness levels for failover. This balanced approach optimizes both cost and performance by maintaining different levels of infrastructure preparedness across regions. Choosing the right data replication strategy is crucial for multi-region architecture. Synchronous replication writes data to all regions before acknowledging the right operation, providing strong consistency but introducing higher latency. Asynchronous replication writes data locally first, then replicates to other regions afterward, offering eventual consistency with lower latency. Multi-master replication allows all regions to accept writes simultaneously, providing high availability but requiring complex conflict resolution mechanisms. Read replicas maintain a primary region for writes while creating replicas in other regions for reads, offering read scalability with simpler management. Each strategy involves trade-offs between consistency, performance, and operational complexity. Multi-region architecture relies on intelligent traffic routing to direct users to the appropriate region. Geographic routing sends users to the nearest region based on their physical location. Latency-based routing is more sophisticated, directing traffic to the region with the lowest network latency for optimal performance. Weighted routing distributes traffic across regions using percentage allocation, useful for gradual rollouts or load balancing. Health-based routing automatically routes traffic only to healthy regions, enabling seamless failover during failures. Round-robin distributes requests evenly across all available regions in a simple, balanced manner. Geofencing restricts access to specific regions for compliance reasons, ensuring data sovereignty requirements are met. Designing multi-region architecture requires careful consideration of 6 critical factors: Data consistency. You must choose between strong consistency, where all regions see the same data immediately, or eventual consistency, where data propagates over time. Latency targets. Define acceptable latency thresholds for different user operations to guide your architectural decisions. Cost management. Balance redundancy requirements with operational expenses and data transfer costs, which can be substantial at scale. Conflict resolution. Implement strategies for handling write conflicts in multi-master setups, where simultaneous updates to the same data can occur. Observability. Monitor health, performance, and replication lag across all regions to ensure system reliability. Compliance. Ensure data sovereignty and regulatory requirements are met for each region where you operate. Multi-region architecture introduces several challenges that must be addressed. Network partitions occur when regions become isolated due to network failures, leading to data divergence and potential split-brain scenarios where different regions have conflicting versions of data. Replication lag causes delays in data propagation between regions, resulting in stale reads and inconsistent user experiences. Data transfer costs can escalate quickly, as cross-region bandwidth is expensive at scale, leading to unexpected operational expenses. Operational complexity increases significantly when managing deployments, monitoring, and debugging across multiple regions, requiring a higher level of expertise and more sophisticated tooling. Understanding these challenges upfront helps you plan appropriate mitigation strategies. Let's examine a real-world example, an e-commerce platform with global presence. At the edge, a global content delivery network caches static assets like images and scripts at locations worldwide for instant access. Regional load balancers use DNS-based routing to direct users to their nearest region while continuously performing health checks. The data layer features a multi-region database with a primary in US East and red replicas in US and Asia Pacific, enabling fast local reads. Regional data stores replicate the product catalog across all regions for quick access, while keeping user sessions local to reduce latency. This architecture provides users with fast page loads, reliable service, and seamless shopping experiences regardless of their location. Follow these 6 best practices for successful multi-region architecture. First, start simple. Begin with active-passive deployment and expand to active-active only when business needs justify the additional complexity and cost. Second, automate failover. Implement automated health checks and failover mechanisms to minimize downtime during regional failures. Third, test regularly. Conduct disaster recovery drills and chaos engineering exercises to validate your failover procedures work as expected. Fourth, monitor everything. Track latency, replication lag, and regional health metrics continuously to detect issues before they impact users. Fifth, design for eventual consistency. Build applications that gracefully handle temporary inconsistencies between regions. Sixth, document everything. Maintain detailed runbooks for regional failures and recovery procedures so your team can respond effectively during incidents.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.